Morning, Year 6. Hello, everyone. Hi, Year 6. Hello. Hi, everyone. Hi, everyone. Happy birthday, Lula. Happy birthday, Stanley. How could we have forgot, hey? Happy birthday. I did, Grace, thank you, yes. Did Stanley and Lula, are you doing anything exciting for your birthday? A barbecue. Oh, that sounds wonderful. It's a lovely day for it as well, isn't it? Oh, I hope you have a great time. Okay, everybody, no, Casey, I can't see you. But yes, Casey, I see you spotted. I'm in the classroom today. So that's really good news. I hope you all heard the news last night that we can return to school on Monday. I can't wait to see you all. It's going to be great to be back in the classroom, isn't it? Yay, lots of yays coming through. Oh, brilliant. Okay, so hopefully then, everybody, this is our final online lesson. So let's give it a go then. Right, so maths one again today. Okay, so before we move on to our lesson then, oh, I've left Thursday on that, that's wrong. Before we move on to our lesson then, and before I switch off to panelists only, how are you all feeling today? Is it like this? Anyone else feeling like that? No, Ashton, how are you feeling today then, Ashton? Oh, you're feeling good. Good. I'm pleased. I was worried then. Oh, I bet you're excited, Lula. Yes. Joshua is reminding you all that we need to be determined today, stick with it and really sustain effort with this challenge, okay? Right, can you switch to panelists only now, please? Thank you, everybody. Okay, first warm up then. Might need a piece of paper to do this on, or you might be able to do it in your head. What is 5,046 take away 413? Oh, Joshua, just to let you know, when you, well, you probably know this already, but when you write in capitals, it looks like you're shouting. So I'm not sure you really want to be shouting. Thank you. Okay, what's the answer to that then? Oh, a whole variety of answers coming in there. If you've given me an answer, make sure you reflect on it. Oh, nearly, Stanley. Casey, just reflect on that again. Joshua, yes, you are. Nearly, Ocean. Yes, Stanley, that's it now. Well done. Okay, everybody. Yes, you are, Grace. Casey, nearly. Yes, Ocean, well done. Good reflecting and improving there. There's your answer. Well done, everybody that got that. 4,633. Excellent. Okay, ratio again today then. Today we're looking at calculating ratio. Again, you need to be really brave, have a go and apply your previous learning. Those of you that are thinking, oh no, Ms. Walker, don't do this to us on our last Friday of remote learning. Let's change the attitude. Let's be positive and let's believe that we can do this. Okay? Because you can. Right, let's jump to it. Hold on, I've lost the chat box now. There we go. Okay, so we know that bar models then show the relative sizes of two or more values. And today we're also going to be looking at bar models. Now we've done bar models a lot in the classroom, and you know that it helps us visualize the calculation and then helps us work them out. So here it says bar models show how numbers can be split into different parts by splitting them into bars or boxes. Bar models can be used to solve a wide variety of calculations, showing the relationships between the whole and the parts. Now you must remember, when we're using bar models, each part of the bar model needs to be equal. So it needs to be the exact same size. Remember that, okay? Hi Thea, welcome. Make sure you switch to panelists now. So, you know this, year 6, remember, just say what you can see. I feel like I'm a presenter on catchphrase. So for every how many blue sapphires, there are how many green sapphires. For how many blue sapphires, there are how many green emeralds. I say sapphires then, emeralds. Thank you, Finn. Casey, just reflect on that. Lula, reflect. Oh no, Lulu, okay, sorry, Lula, I didn't mean to say your name then. Casey, reflect. That's it, Ocean, well done. So how many blue sapphires can you see? And how many green emeralds can you see? Count them again, Casey. That's it, Ashton. Remember, Ashton, you set it out with the colon in between. That's it, Jamie. That's it, Stanley. Well done. That's it, Charlie. That's it, Ashton. Theo, we're carrying on with ratio today. That's it, Casey. Well done. So we've got 6 blue sapphires and 8 green emeralds. So the next part of the question, for every 3 blue sapphires, there are how many green emeralds? So to get that amount of blue sapphires, they started with 6, they've now got 3. So they've divided that by 2. So remember, you need to do the exact same with the green ones. What's the new ratio? That's it, Ocean, well done. Yes, Jamie, well done. Yes, Grace. Theo, you need to do the same with the green emeralds, okay? Yes, Charlie. So you started with 8 green emeralds. You need to divide that by 2. That's it, Harry. That's it, Stanley. Ashton, Kyan, Casey, you need to reflect there, please. Because remember, what you do to one, you need to do to the other. So we started with 6 blue sapphires here. Then they've changed it to 3 of them here. So they've halved that or divided it by 2. So you need to do the same with the 8 green emeralds. Yes, Casey, well done. So 8 divided by 2 is what? Well done, everybody. 4 green emeralds, okay? Right, let's look at some word problems then. So what is this question actually asking us to do? Freddie is making a smoothie. He needs to use 2 bananas for every 9 strawberries. If he uses 6 bananas, how many strawberries does he need? So you need to see there what has actually happened. No, they're not quite. So he starts with 2 bananas for every 9 strawberries, but now he's gone to 6 bananas. So what's happened in that calculation? We started with 2, we've gone to 6. How have we got to 6 from 2? What's Freddie done? He's times it. Yes, correct. Well done, everybody. He's times it by 3, hasn't he? So you need to do the same for the 9 strawberries. So 9 times 3, everybody. Well done. Yes, Finn. Yes, Casey. Yes, Lula and Jamie and Harry. Well done. Not quite, Stanley. Yes, Florence. Ocean, well done. Ashton, Kai. So it will be 9 strawberries multiplied by 3, which will give you an answer of 27, because our original ratio looked like this, 2 to 9. Then we know it's been multiplied to get to 6. So we will now have 6 to 27. So 2 times 3 got us 6. 9 times 3 gets us 27. So Freddie needs 27 strawberries. Because remember, what you do with one, you need to do with the exact same with the other value. So let's read this one again. Jemima is making a pie. She needs to use 2 potatoes for every 5 carrots. If she uses 20 carrots, how many potatoes does she need? So let's start with step 1. Just at the very beginning, how many potatoes does she start with? 2. Excellent. And how many carrots? 5. Well done. Now she's gone to 20 carrots. So what has she done with this 5 carrots to get to 20? What has she multiplied it by to get from 5 to 20? Yes, well done, everybody, at saying that. She's multiplied it by 4, hasn't she? So now, if we look at our 2 and we multiply it by 4, we're now going to have how many potatoes? Yes, 8. Well done. And then the carrots, we know she's multiplied by 4 and she's going to have 20. So how many potatoes does Jemima need? Yes, it's there for us, isn't it? 8. Let's check. Well done, everybody. Excellent. Okay, let's look at this one. Ahmed is making a cake. He needs to use 15 grams of butter for every 20 grams of flour. He says, if I use 45 grams of butter, I need to use 50 grams of flour. Is he correct? Yes or no? Is he correct? Yes or no? Okay, Finn, how did you get to that number? What have you done? What type of calculation have you done, Finn? Yes, Grace, of course I will. Yes, I know it's multiplying, Finn, but I want to know what number. What number are you multiplying it by? Okay, year 6. I think what you're doing here is you're getting yourself a little bit muddled up because it's written in words rather than digits. So we've got 15 of butter and we've got 20 grams of flour. He's now jumped to 45 grams of butter. So to get from 15 to 45, what type of calculation is that? We know it's multiplying, but how many does he need to multiply it by to get from 15 to 45? Yes, Stanley, thank you. What do you need to multiply to 15 to get 45? Yes, Grace, well done. So 15 times 3 would be 45. So we need to do the same for the flour. We need to times it by 3, don't we? So 20 times 3 will be what? Yes, Stanley? Yes, Grace, well done. Everybody, you got it. It'd be 60. And he's telling us here that he needs 50. So is he correct? Yes or no? Well done, well done, well done, well done. Well done, everybody. Excellent. Okay, let's look at this other word problem. A florist uses sunflowers and lilies in her bouquets. For every 3 sunflowers, she uses 5 lilies. In an extra large bouquet, she used a total of 25 5 lilies. So how many sunflowers did she use? I'm just going to get a whiteboard and pen a second whilst you guys have a look at that. Okay. So here she started with 3 sunflowers. I'm just going to label it so we don't get muddled up. Can you see all that clearly? And then she's doing 5 lilies. So that's the original ratio. Okay. Now she's saying for the second one, she's got 25 lilies. So to get from the 5 to the 25, what she multiplied that by? Thank you, Charlie. Yes, well done. She's multiplied that by 5. So what does that mean? What have we got to do on this side? Times it by 5, yes. So then 3 times 5 will be 15. So how many sunflowers has she used? 15, well done. But then there's one more part to that question. How many flowers are there in total? So that means we've got to add these together now. We've got to add those ones together. Well done, everybody. 15 add 25 will give us 40. Let's check. If you can't see me, somewhere on your screen, you'll probably see like a smaller screen and you can expand it or minimize it, okay? So there it is on the screen for you, exactly what we've just done together, okay? So we times it by 5, both sides, and the new ratio is 15 to 25. And we know that there are now 40 flowers in total. Okay, let's look at this one then, we'll do it together. Let me just wipe that off. So we'll look at the question. So remember, like any problem that we do, you need to write down the important information, don't you? So in this case, it's the ratio. So a model village builder uses 4 red bricks. So we know we've got 4. I'm going to label it so I know that they're the red ones. And we've got 7 yellow. So it's going to look like that to start with. For the skyscraper, he used 28 red bricks in total. How many yellow bricks does he need? How many bricks will he use altogether? Right, the first one we've just done together, because that's what I've just written here. So we know that there are 4 red bricks and that there are 7. Oh, I've got it the wrong way around, have I? No, that's right. So identify the ratio, how the ratio is changed. So it says now that he's got 28 red bricks. So what do I need to do? He's now got 28 red bricks. How has he got from 4 to 28? What's he multiplied it by? Well done, everybody. So he's multiplied that by 7. So the same has to happen with the yellow ones. So 7 times 7 will be 49. So if we complete this here, complete both sides of the ratio by 7, identify the new ratio. So the new ratio will be 28 to 49. So the builder needs how many red bricks now? I'm sorry, how many yellow bricks does he need? It's there on the screen for you and in the ratio that I've just typed. How many yellow bricks does he need? Look here, guys. Remember we talked about the other day being the first one, the first object goes first in the ratio. So red is 28, yellow is 49. Well done. So what we've done is made this ratio bigger. He started with 4 red bricks, and then he ended up with 28 red bricks. So to get from 4 to 28, he's multiplied it by 7. So remember, we need to do the exact same for the yellow. So how many bricks does he need all together? So that means you're going to have to add these two together. 28 add 49. 28 add 49. Oh, a whole mixture of answers coming in there. So 8 add 9 will be 17. Now I'm doing the 10s. Good. Well done, everyone. 77. Let's check our answers. Brilliant. Well done, everybody. Right, we're going to bar models now. So the other day when we were looking at this, we had pictures of round counters. This is the same, but it's in a bar. It's in a bar, okay? So Andy has bought a box of marbles. And he's got 3 purple marbles. You can see them there. So for every 3 purple marbles, there are 4 green marbles. However, there are 35 marbles in the box altogether. How many marbles of each colour are there? Now, when you look at that question, it may be confusing. However, if you think back to how we've done bar models in the past, and we talked about parts, we can see that there are 3 parts that are purple, and there are 4 parts that are green. And if there are 35 marbles altogether, what are we going to do with these parts that we've got here? What could we do? No, not multiply, Casey. How many parts have we got altogether? We've got 7 parts altogether, haven't we? Yes, Casey, good. We're going to divide them. We're going to divide them. So we know that we've got 35 marbles. And then we're going to divide that by 7. Hopefully, when this comes up on the next screen, you will remember this. So look, there are 7 parts in total. So this here, these parts total the whole, okay? And we know that there are 35 marbles altogether. So we need to divide that by 7 parts, which will give us 5. So you then put 5 in each of these parts. Now we've done this in bar models before. So then we can now see 3 times 5 is how many purple marbles? 15. And how many green marbles are there? 20. Now, how are we going to check that our answer is correct? How are we going to check that the answer is correct? How are we going to check? What do you think? Yes, Stanley, thank you. So you need to add these together. Casey, you don't need a calculator for 20 add 15. 20 add 15, we know, is 35. So we've checked our answer, and yes, it all adds up. Yes, Theo, well done. I'm pleased to say that when we come back next week, because we're definitely coming back, we can do loads of these in the classroom and you will be able to see it, okay? Right, Here's another bar model. So we can see the clownfish and the angelfish. And remember, you have to label them so that you can see which part is which. So at the aquarium, fish can live in tanks with a ratio of 5 clownfish for every 7 angelfish. So that's why this clownfish bar has been divided into 5 parts. And the angelfish bar has been divided into 7 parts. They've just had a delivery of 48 new fish in this ratio. How many clownfish and angelfish have been delivered? So the total number of fish is 48. What do we need to do next? What are we going to use this information for? We're going to divide that 48. Yes, Stanley, thank you. But divide by what? Divide by what? Yes, Grace. Why that amount, Grace? Yes, Casey. Why that amount? Yes, Grace, well done. So Grace says we're going to divide by 12. Yes, Ashton Kai, well done. We're going to divide by 12 because if we add up the amount of parts for clownfish together with the amount of parts for angelfish, that adds up to 12. So 48 divided by 12 is what, year 6? 48 divided by 12. Yes, Casey, thank you. So that means each part here, each of them is worth 4. Because 48 divided by 12 is 4. So I need to put in each of these parts that they are worth 4. Good, Lula, good. I'm glad you do. So now we're going to be able to find out how many clownfish there are altogether. How many clownfish are there altogether? Yes, Casey, well done. Yes, Theo. Yes, Ashton. Yes, Grace. Yes, Ocean. So you need to add these ones up all together to find out how many there are. So it's 5 times 4 really, isn't it? 4, add 4, add 4, add 4, add 4. And the answer is 20. So there are 20 clownfish. How many angelfish are there? Thank you, Ashton. Yes, well done. Oh, Casey, just reflect on that. Yes, Finn, well done. Yes, Jamie. Yes, Florence. That's it, Casey. Well done. So there are 28 angelfish. Let's check. Well done, everybody. Excellent. Right, let's have a look at this one then. Sometimes we will be asked to compare 2 different ratios. So Harrison has bought 2 packs of stickers. In the first, there are 2 shiny stickers for every 4 regular stickers. So 2 shiny to 4 regular. That looks like that. 2 shiny to 4 regular. And that's in the first pack. In the second pack, label it like that, there are 3 regular stickers for every shiny sticker. So that's 1. You all see that? Sorry, it's hard writing on the board this way around. So the first pack, there are 2 shiny stickers for every 4 regular stickers. And then in the second pack, there are 3 regular stickers for every shiny stickers. So there are 36 stickers in each pack. Which pack contains the most stickers? What do you think I can do to help me solve this calculation? What can I do? I'm going to have to create a bar model with each part equal for pack 1 and pack 2. So if we do pack 1 first, okay, I'm labeling it. I'm going to pack 1 first. And pack 1, if we look at the ratio, we've got 3 parts. It's not 3, sorry, 2 parts that are shiny and 4 parts that are regular. So I've got a bar model that looks like that. Can you see the shiny part and the regular part? How many parts have I got all together? How many parts have I got all together? 6. Excellent. So what am I going to do with that information? Okay, Finn, you've given me an answer, but you need to prove it, please. What do I need to do with these 6 parts? We know that we've got 30. Okay, Grace, just listen to what I'm saying then, sweetheart, if you can't see the screen. So we know that we've got 36 stickers altogether, and we know we've got 6 parts. So what's the calculation that I need to do? Right, those of you that are trying to work out which pack has the most, can you just focus on this, please, rather than trying to work that out, because you're going to miss this part of the learning, and this is how you work it out. Yes, Ashton Kai, thank you. So it'll be 36 divided by 6, which, as we know, is 6. So I now need to label each of these parts. Okay, so now I can see that the shiny stickers, there's 2 parts. 6 adds 6. Grace, I know you can't see it, sweetheart, but just make sure you're listening, okay? So the shiny stickers, we've got 2 parts. 6 adds 6 is what, everybody? 6 adds 6. Yes, thank you, Grace. So 6 adds 6 is 12. So in pack 1, there are 12 shiny stickers. And there are 24 regular stickers. We now need to do the same for pack 2. So we start with, there are 1 shiny sticker to every 3 regular stickers. So this is pack 2. How many parts have I got now? This is pack 2 here. How many parts? Yes, thank you, everybody. I've got 4 parts now. 1 part is shiny and 3 parts are regular. So that makes 4 altogether. So we need to do another dividing calculation here. 36 divided by 4, because we've got 4 parts. 36 divided by 4, which is what? Thank you, Theo. 9. So then the value we need to put in each of these parts, 9, 9, 9, 9. So now we can see that in pack 2, there are 9 shiny stickers, and that there are 3 times 9, guys, for the regular stickers. What's 3 times 9? Thank you, everybody. 27. So let's go back to the question, because we've got our answers now. Which pack contains the most shiny stickers? So in pack 1, there are 12 shiny stickers. In pack 2, there are 9 shiny stickers. So which pack has the most shiny stickers? Yes, well done, everybody. Pack 1. Pack 1 has 12 shiny stickers. So you need to be very careful with problems like that. You need to make sure you definitely know how many there are. Right, year 6, we're coming to the end of the lesson now. So I'm just going to go to the problem really quickly. And I just want you to remember that we will look at this in the classroom next week, okay? So don't worry too much. Okay, so Hayley, the shop assistant, is arranging fruit hampers. The shop manager has asked her to include 5 apples for every 2 pears and have a total of 28 pieces of fruit. So she says that I need to include, oh, that's gone too big. I need to include 24 apples and 4 pears to keep the ratio the same. This is because 24 add 4 equals 28. Do you think she's correct or not? So the ratio is 5 apples to 2 pears. And what she's saying is you need to do 24 add 4 equals 28. Do you think that's right? No, of course it's not. So if we look at the example here, so she's not multiplied to keep the ratio the exact same. She's used addition facts rather than ratio information, okay? So she's not kept the ratio of 5 apples for 2 pears the same, okay? So year 6, have a go at the challenges that I've put out for you this afternoon. Remember that sometimes when you have a go on your own, it makes a little bit more sense. Otherwise, don't panic too much, and we will do this on Monday, these exact same calculations, because I know I've had to race through an awful lot of information there. Okay, right, everybody. I hope you all have a lovely afternoon. Remember that there is Learning Hero or Celebration Assembly at 2:50 p.m. Enjoy your afternoon and your weekend, and I will see you all in the classroom on Monday. Lula and Stanley, I hope you have a fantastic barbecue to celebrate your birthday. Oh, you are so welcome, Grace. I want to say well done to all of you, year 6. You know, you've been great through all of this. It hasn't been easy. So thank you, year 6. And thank you to your grown-ups if they've helped you as well. Okay, everybody. Bye, everyone. See you on Monday. Bye.